So for this problem, I'm demonstrating chapter 11.1. In this problem, we will test for expected value and goodness of fit. For my problem, I chose to do skydiving deaths observed versus expected in the United States. So in this table, it shows the year and then the observed number of skydiving deaths. So in 2008, 30, there were 30 observed deaths or reported deaths, and so on. So to start, we need to run a hypothesis test, and the null will be there is no difference in the amount of skydiving deaths each year. And the alternative will be there is a difference in the amount of skydiving deaths each year. So next we have to solve for the expected values, and to do that we need to find the percentages of deaths worldwide. So there are about 500,000 worldwide jumpers each year, and on the same website that I got the other stats, it gave me how many worldwide deaths were recorded each year, and in 2008 there were 64. In 2009 there were 68. And in 2014 there were 36. So once we have these, next we will divide each one of these by 500,000 to get the percentage. So that'll look like this. For the first year for 2008, it's 64 divided by 500,000 equals 0.000128. And you'll do this for each one. After you've calculated all that, these will be all your percentages. Move those up there. So next you will multiply each one of those for each year by the amount of jumpers in the United States, which is around 350,000. So it'll look like this. For 2008, this will be 0.000128, and that gives you 44.8. And you'll do that for each one. After you do that, you'll take each value and put them into the expected row for the chart. And that'll look like this. So you'll have the values you just calculated, and you'll put them in the frequency expected. And then after that, we're going to make our graph. So we'll start like this, and in this chapter, all graphs are right-tailed. And we will be using a 0.05 level of significance, so alpha equals 0.05. 0.05. And first we need to find the critical value. And to do that, you go to inverse on your calculator. And it'll be inverse chi-squared. That'll look like this. So you put in 0.95 for the area, and the degrees of freedom are 6 because we are testing 7 different years, and it's n minus 1. After that, you will get this as an answer. So 12.592 will be your critical value. So that'll go right here. Next, we need to find your test value. And that is found by going into your calculator and into stats list, and then inserting the data into list 1 and list 2. So you'll put your observed data in list 1 and your expected data in list 2. That'll look like this. Then you will put it, once you hit enter, you'll go to F6 and then 7 chi-square goodness of fit test, and then hit enter. Look like this. So we found that our test value is 54.153. So it's clearly in the critical region, so we reject. So our statement will be, since we rejected, there is evidence to state that there is a difference in the number of skydiving deaths a year. After this, we just have to do one more thing, and that is to do our goodness of fit graph. After you made your graph, we got to plot the points. I'll be using red for the observed points and blue for the expected points, and we'll start with expected. So we have the expected line, and then now we have the observed. With this graph, you can clearly tell there's a difference between the expected and observed. This is my problem for chapter 11.1. Thank you.